One of the most commonly done thing using calculus is to find the tangent line and by extension the normal line through a certain point. The tangent line we already discussed and done some example before, so that part should be familiar. But normal line is kind of the same thing. So let's see here. What if I want to find the equation of the tangent line to the curve at that particular point? Well, the tangent line will have a slope y prime equals to 10x. Since x is 3, then y prime is 30, right? So in other words, I have a line that has a slope of 30, which goes through the point 345. So what kind of equation do I have? I prefer the slope the slope point form, which is y minus 45 is equals to 30 and then x minus 3, right? So y is equal to 30x minus 90 plus 45, so minus 45. So that will be my tangent line equation for that. Nothing too crazy here. If you want to do the y equals to mx plus b form, that's perfectly fine. Solving for b. Let's do the next one. Find the equation with the tangent line at that point. Well, y prime is equal to 3x squared plus 2x. And y prime at 3 is going to give me 3 times 9, 27, plus 6, 33, right? So again, m equals to 33, and the point is 336. So y minus 36 is equal to 33, x minus 3. So y equals to 33x minus 99 plus 36, which is the same thing as minus 63. And that's the tangent line equation. Now, find the equation of the tangent line to this particular problem. Well, gotta do quotient rule. So again, u equals to 2x plus 5, u prime is 2, v is x squared minus 3, v prime is 2x, and vu prime. So 2x squared minus 3 minus uv prime, 2x plus 5 times 2x divided by v squared. So x squared minus 3 squared, right? Okay, I'm not going to bother simplifying it because I feel like just plugging number might be easier at this point. So y prime or m is equal to plugging numbers. So that's 2 times negative 2, so that's negative 4. That's minus 7 times 2, 14. This one's going to be just negative 2 squares of 4, right? So it's negative 18 over 4 or negative 9 over 2. That's the slope. And the point that I'm going through, x did just tell me x equal to 1. I don't know the y, but I can solve for y, right? Plugging here, y is 2 plus 5 over 1 minus 3. So it's 7 over negative 2. So that's my y point. So again, I know the slope, m is negative 9 over 2. The point I'm going through is 1, negative 7 over 2, right? So doing that, y plus 7 over 2 is negative 9 over 2, x minus 1. So y equals to negative 9 over 2x, minus 9 over 2, minus 7 over 2, so that's 16, so minus 8. And that will be the equation of the line that's tangent to that equation at x equal to 1. All right, now, why don't you guys give this problem a try? Let's see how we do. Okay, good. I actually think all of you got it correctly, so good job. So the final answer is negative 7x plus 8. So good. Okay, I think I can skip going over that. So let's move on to number 4. Find the equation of the line normal. So be careful. Sometimes that's for tangent, sometimes that's for normal. So what is normal? Well, if I have an equation that has a certain tangent line here at this point, a normal line is a line that is just going to be perpendicular to it. That's all that is. A line that is normal to the tangent line is called the normal line at that point. So, and you probably guessed how we're going to do this. So essentially, we're going to do the derivative equals to 5x4 minus 4x3. The 1 drops out. At equals to 2. X equal to 2. Plug it in. I'm going to get 80 minus 32. is going to be 48, right? So that's it. So since y prime is equal to 48, the tangent line slope will be 48. Then the normal line slope will be negative 1 over 48, right? That's all that is. Instead of using the tangent line slope directly, you're going to find the negative reciprocal of it, or the normal line slope. And it still goes through the same point. So 2, plug it in. 2 to the 5th is 32, 2 to the 4th is 16, plus 1, so this is 17. So the point is 217, and the slope is that. So, well, y minus 17 is equal to 1 over negative 48, x minus 2. So y equals to negative x over 48 plus 1 over 24 plus 17. So I guess 17 and 1 over 24. You can put this into a mixed number. This is a mixed number. If you want to put it in an improper fraction, you could, but I'm not going to bother. So that's something like that. Yeah, pretty straightforward. All you needed to do is, instead of doing tangent line, we'll do a normal line. So that's that. Okay, let's try problem 2. Yep, good job. Most people got it right. So it is a 6. Sorry, y prime is equal to negative 1 minus 2x. Okay, negative 1. We're going to get y equals to 1. So then, so now y prime is equal to 1. So the m that we want is negative 1, right? What's the point that we need? Plug it in. 6 plus 1 minus 1 is 6. So it's negative 1, 6, right? Plug it in. Y minus 6 is equal to negative 1 x plus 1. Okay, y equals to negative x minus 1 plus 6. So it's negative x plus 5. Yep. All right. Let me see. I think I'm going to pick some problems for we to do. We don't necessarily need to do all of them. Definitely I want you guys to try number 5, but let's go ahead and do number, you know what, all of them are pretty represented. Actually, we're going to skip 3, because problem 3 just asks you, this is the equation, find the tangent line and the normal line to that, which I think you guys know what to do. But let's take a look at number 4 and 5. These are a bit of a challenge, a little twist on the things that we did, but nonetheless, it's still fairly simple. So let's try it out. The curve, which is the parabola, passes through the point 2,4 and is tangent to the line y equals to x plus 1. Find a, b, and c. Very good. Yeah, one of you sent the answer, and that is correct. So, all right, again, in the interest of time, let me start working this out. And you can check how far you got, or if you have the same logic as I did. Okay, so we are going to figure out what A, B, C is. What are some pieces of information we have? 2, 4, the coordinate that's on the graph. So I can use that to help me set up some equation first, which means I can plug in the original. I get 4 equals to 4a plus 2b plus c, right? So that's one thing that may be useful for me. And then it says it's tangent to the line at x plus 1 at 0, 1. So if it's tangent to it at that point, which must mean this also goes through that point. So in other words, 1 is equal to a times 0 plus b times 0, those are gone, plus c. So right off the bat, c equals 1. Great. And I can replace this c with 1. What else have I not used? I've used this point. I've used this point. What other information I might use? Tangent to that line. In other words, this line is tangent to that. So what's the slope here? M is equal to 1. That's the slope at 0, 1. So in other words, the derivative of this function, y prime equals to 2ax plus b at 0, 1 would give me a slope of 1. So in other words, 1 is equal to 2a times x plus b. And what's x? X is 0. So b is 1. Now I have this equation I can change. 4 equals to 4a plus 2b, so it's plus 2. plus 1. So 1 is equal to 4a. A is 1/4. Altogether, y is equal to 1/4 x squared plus x plus 1. That's it. Okay. All right. Cool. So that's that. And you can see that, in algebra 2 or maybe pre-calc, we know how to get a quadratic equation. If you're given like the vertex and the intercept, you know how to get the quadratic equation. If you are arbitrarily given 3 different points, now you have one more method. You can get a tangent line and a point. You'll also be able to figure out the equation for the quadratic. So that's all right. Now, number 5 is actually a lot easier, but this one, we do that a lot, especially when it comes to like uh, optimization problems later. But we're trying to figure out where does the function has tangent line that is parallel to the x-axis. Think about what it means, and let's see if we can solve it. Okay, let me go over this as well. So we have 2x cubed minus 3x squared minus 12x plus 20. We want the tangent line to be parallel to the x-axis, which means it's a horizontal line. A horizontal line has a slope of 0. So in other words, all we're doing is try to solve for y prime, which is equal to 6x squared minus 6x minus 12 is equal to 0. Divide everything by 6, x squared minus x minus 2 is equal to 0. So x minus 2, x plus 1 is equal to 0. So what are the points? X equals to -1 or x equal to 2. Now you can plug back these into the equation to get the actual coordinates, but that's it, right? Fairly straightforward. Yeah. Okay. All right. Cool. Okay, let's move on to the other topic for today, which is Rolle's theorem and the so-called mean value theorem, both of which are very kind of intuitive in a way. And let's see here. Rolle's theorem says if f is a continuous function and is differentiable on the same interval, notice how they label it slightly differently. Like this is continuous, which is inclusive, but then the differentiable is not inclusive, which makes sense because differentiable usually is you cannot do a closed interval. And then if the beginning point, so this is the y value, so if y1 is equal to y2, there exists at least one point C in which that the prime of C is 0. So what does that mean? So if you have a continuous and smooth function, if your beginning point and end point are both the same horizontal level, then you're guaranteed somewhere in the middle of your graph, you're going to have a tangent line that's equal to that, which kind of makes sense. Like, what does it mean? So if you draw a point over here, draw a point over here, if they're on the same level, that means your average change is 0. Then somewhere in the middle, you're guaranteed to have your instantaneous change to be 0, right? So in this case, I will get several zeros. There's no way you can draw a graph like that you want to start and end at the same level, but not have anything that's like flat in the middle, as long as your graph is continuous and differentiable. If you look at the second graph here, this is continuous but not differentiable. So that doesn't work, right? This graph doesn't have any slope of 0. And yeah, so that's now, how do we use Rolle's theorem? Well, we can somehow show it, exemplify it. Let's say that if Rolle's theorem is true, then I must have some point between the two x-intercepts that has 0, because the two x-intercepts will be on the same level, right? So what are the two x-intercepts? The x-intercept in this case will be x minus 2, x minus 1, right? If I factor it. So x equals to 1 and x equals to 2 are my intercept. So therefore, the theorem says I'm guaranteed to have a point C somewhere between 2 and 1 that's going to give me a slope of 0. Let's try it. So how do I get the slope? y prime is equal to 2x minus 3. When is this equal to 0? 2x equal to 3, x equal to 1.5, and that's precisely between 1 and 2. Right, so that's just an exemplification of how the Rolle theorem turns out. Now let's illustrate this one more time. Let f be that, find all the values of c in the interval such that f prime is equal to 0. So the interval, how do we use this? We can say, okay, this sounds like a Rolle theorem. So what are Rolle theorem's criteria? One, is f of x continuous? Yes, that's a continuous function. Is it differentiable? Yes, it is differentiable. So I'm good with the first criteria. Second criteria, is f of -2 the same as f of 2? Well, let's try. F of -2 is going to give me 16 minus 8 equal to 6. 8, sorry. And then f of 2, same thing, because this is an even function, right? So this is going to be 16 minus 8 equals to 8 as well. So yeah, they're the same value. So therefore, Rolle's theorem should guarantee me at least there's 1 point in between -2 and 2. I should get a 0. So let me try. 4x cubed minus 4x is equal to 0. So if I factor it, 4x, x squared minus 1 equal to 0. So x equal to 0 or x equals to plus minus 1. So in fact, I have like 3 different points in between -2 and 2 that satisfy this criteria. Right. So that's it. Okay. Now, you try problem 4. Find the value of c that satisfies Rolle theorem for f of x equals to x fourth minus x. All right. Let me start going over that. Find the values of c that satisfy Rolle theorem for that. So, well, assume Rolle theorem applies here, does it? F of 0 is 0, f of 1 is 0. Yes, they both have the same value, so Rolle theorem should apply. This is also continuous and differentiable, right? So therefore, f prime of x is simply 4x cubed minus 1 equal to 0. So x cubed is equal to 1 over 4. X cubed, x is equal to the cubic root of 1/4, whatever that value is, right? Doesn't matter, you can plug in a calculator, but this is it. And we know the cubic root of 1/4 is somewhere between 0 and 1, for sure, right? So we're good. All right, cool. So that's Rolle theorem. Now we're going to expand that a little bit. In fact, the Rolle theorem is simply a special case for the mean value theorem. The mean value theorem says if f is continuous on the closed interval a, b, and differentiable on the open interval is the same setup, and there must exist a number c in a, b such that f prime of c, so the slope at that point, is equal to, does this look familiar? This is simply y2 minus y1 over x2 minus x1, right? So if your first point is AFA, your second point is BFB. This is literally what it means. So what the mean value theorem states in effect is that if the function is continuous and differentiable, you must have a tangent line in between those two endpoints that has the same slope as the secant line. And what does the secant line slope means? Secant line slope is the average rate of change. So somewhere in your journey, you will have the average value. Right? It kind of makes sense, right? Like, let's say you drive from Los Angeles to San Jose or Cupertino, right? If your average speed is 50 miles per hour, somewhere in your journey you must have hit 50 miles per hour. So that's the idea, right? Very straightforward and very intuitive, but mathematically kind of cool, I guess. Let's see here. For f equals that, find all values in the open interval such that the mean value theorem is satisfied. So what do? We need to actually find the secant line first. So the secant line is, well, f of 4 is 4, f of 1 is 1, right? So it's 1, 1, and 4, 4. So check it out, that's 3 over 3 equals to 1. So somewhere I must have a slope of 1 between 1 and 4. Do I? So f prime is equals to 1 equals to, well, this is plus 4 over x squared. right? So in this case, x equal to plus or minus 2 for that to occur. Again, I took the derivative. The derivative of that is, negative 4x to negative 1, so it's positive 4x to negative 2, so it's like that. Right, so x equals to plus or minus 2. In this case, only x equals to plus 2 is between 1 and 4, but that doesn't matter because I only need to guarantee one point is in there. That's it. So x equal to plus 2 is a point C within this interval that satisfies the mean value theorem. If I look at the graph, that's what it is. All right, from 1, 1 to 4, 4, here is the average rate, and at 2, I hit the average. Anytime before 2, I have a rate that's slightly bigger than that. Anytime after 2, I have a rate that's slightly lower than that. So here is the point where I hit the average rate. Now, a further application of this, like the one I did, two stationary patrol cars equipped with radar 5 miles apart on highway, shown as truck passes the first patrol car, its speed is clocked at 55 miles per hour. 4 minutes later, when the truck passes the second patrol car, its speed is clocked at 50 miles per hour. Prove that the truck must have exceeded speed limit of 50 miles per hour at some point during the 4 minutes. Yeah, I think this is a clever way to apply this. Why? Because when you see police, you slow down, right? Because you don't want to get a speeding ticket. But they can still figure out because if you covered 5 miles in 4 minutes, what is your speed? That's 5 miles for 4 minutes. And I know for every 60 minutes, that's an hour, right? So that's 300 divided by 4 miles per hour, which is 75, right? So your average speed between these 2 points is 75 miles per hour. So you have to, if your average is that and your beginning speed is and the end speed is that, you're guaranteed by the mean values, you're guaranteed to have hit that value somewhere in the middle. In fact, you probably far exceeded the 75 in the middle, right? And does that fulfill the criteria? Is the speed of a car continuous and differentiable? Sure. Yeah, it has to be continuous. You just speed doesn't all of a sudden jump, right? You have to accelerate from 0 to a certain value or deaccelerate from a certain value to 0, right? So it's continuous and differentiable. So that's that. So that's applying this in real life, essentially. Okay. I did have a couple problems for you guys to practice with, but I think we're running out of time. So let me just do them real quick. Find the value of C that satisfies the mean value theorem with derivative on this interval. So again, 0, 1. First of all, the business of mean value theorem is to find f of A and f of B, right? So f of A is -1, so we have 0, -1. F of B is 1 plus 2 minus 1, so 2, so 1, 2, right? So what's my slope? 2 minus -1 over 1 minus 0, that's 3. Yeah, slope is 3. To have a 3 equals to 2x plus 2, that's the derivative, right? Prime. 3 equals to 1 prime. So 2x equals to 1, x equals to 1/2. Yep, right in the middle. Second one, find the values of C that satisfy this on this interval. So f of 1 is 2, so 1, 2. F of 2 is 9, so 2, 9. What's the slope? 7 over 2 minus 1 is 1, right? So slope is 7. In other words, 7 is equal to 3x squared. X squared equals to 7 over 3. X is equal to square root of 7 over 3. There's a plus minus, but we're only going to take the plus, right? And is this some number between 1 and 2? I'm pretty sure because 1 is the square root of 1, 2 is the square root of, let's say, 12 over 3, right? So yeah, this is 7 over 3 is definitely between that. So, okay. Find the value C that satisfies the mean value theorem for this particular function for the interval. So same idea. F of -4 is going to give me -4 minus 1 over 4. So minus 25, no, 17 over 4. And then f of +4 is, this is kind of symmetrical, right? So it's 17 over 4. Yeah. And so we have 17 over 4 minus -17 over 4. And we have the distance between them is 4 minus -4, so we get 34 over 4 divided by 8. So 34 divided by 32. That's still 17 over 16. Okay, that's my slope. 17 over 16 is equal to y prime. 17 over 16 is equal to y prime is 1 minus, because this is x plus x to the minus 1, right? So minus x to the negative 2. In other words, 17 is equal to, actually minus 1 on both sides. I get 1 over 16 is equal to negative 1 over x squared. So I get, I guess I get an imaginary number. So let me check. X plus 1, is that continuous and differentiable in this interval? Nope. This is not differentiable because at x equal to 0, I have an asymptote, right? I have something maybe looking like that, I think. It's not a continuous function. So I cannot apply the mean value theorem. I should have checked that earlier. Oh no, cannot apply mean value theorem because this is not a continuous and differentiable function. That's all. Okay, that's it for today. Hopefully you guys don't feel too rushed at the end. But yeah, so the mean value theorem and the Rolle's theorem is kind of intuitive. You just got to remember kind of like physically what it means and try to solve it that way. All right. Homework will be assigned later tonight and will be due Wednesday, 1 hour before class. So 3:15. Yeah, 3:15 will be when the homework's due. Please try to finish them before then. All right. See you guys next time.
Is class on Wednesday a different time?
Yeah, class on Wednesday is a different time. Monday and Friday is 6 to 8. Wednesday is 4:15 to 6:15.
Got it. Okay, got it. Thank you.
Will that time work for you? Do you have a conflict?
It should work. Yeah.
It should work. Okay, sounds good. Okay, all right.
Thank you.
See you guys. Bye.
Thank you.